Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar, brought to you by TechStrong and Fairwinds. My name is Cody J. Brown. I'm the host of TechStrong Learning, and we've got an exciting presentation for you today. First, a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to go ahead and send those in to us using the Q&A tab, which can be found on the right side of your screen. That's also where you're going to find the chat tab, where we want you to get to know the rest of your audience members. Let us know your thoughts throughout today's program, or just tell us where you're tuning in from. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around to the very end. Our topic today is Kubernetes Guardrails and why you need them. And I'm joined by Robert Brendan, Vice President of Product Development at Fairwinds, and Kendall Miller, Technology Evangelist at Fairwinds. Robert, Kendall, thank you both for joining me. I'm going to turn the floor over to you.
All right. Well, welcome, folks. I'm still getting a few last-minute things here prepped, but I think I'm good to go. Glad to have you. We are going to be talking today about Kubernetes Guardrails. Kubernetes is still big and new and complicated for most people, and it feels a little bit like driving wild on a road you're unfamiliar with, and it would sure be nice if you knew where those guardrails were so you don't go swerving off, right? I'm going to make lots of guardrails comments throughout this, and some may or may not be particularly coherent, we'll see, but yeah, where are the guardrails? Why are they needed? How do they help you as an organization? What's the relationship between guardrails and service ownership? We're going to be talking about all those things today. Kubernetes needs some guardrails in the vast majority of situations, and we're going to be talking about that. So let's go ahead and dive in a little bit. First, Robert, we mentioned your title, but tell us a little bit about what you do at Fairwinds.
Yeah, so my name is Robert Brennan. I've been at Fairwinds for a little over 3 years now. I lead up our software development efforts. So I work on a combination of open source projects like Polaris and Goldilocks, as well as our commercial offering, Fairwinds Insights.
And my name is Kendall Miller. I've been at Fairwinds for 7 years and about a month, which is kind of ridiculous to say out loud. Very long time. Anyways, glad to be here. Kind of done everything in this organization. Happy to talk to you today about guardrails, about Kubernetes, about the changing landscape therein of all of these things. And yeah, let's go ahead and dive in. So real quick, if you're unfamiliar with Fairwinds, Fairwinds looks to be, it's our mission to be a trusted partner for Kubernetes security, policy, and governance. We want to help organizations ship faster. So we have a long history building and maintaining Kubernetes clusters for organizations in a service capacity. And then from our macro view of all of these organizations running Kubernetes clusters, we started to build a bunch of open source that addressed common problems that we saw these organizations struggle with. We still have a whole bunch of open source. We're going to get a little bit into that towards the end, talk about what some of those projects do, where they fit. Today, our primary focus is building a SaaS platform for people who are using Kubernetes and want guardrails. That's why we're talking about this today. We help organizations implement policy, really unify dev, sec, and ops by giving you great defaults out of the box, making it easy to implement across large organizations, et cetera. At the end, we are going to show a brief demo of the software, so stick around. But that's what Fairwinds does. This is all we do. It's literally Robert's life. He lives and breathes Kubernetes guardrails, so we're excited to be here and talk with you about this. First, before we get started, let's have a polling question. Where are you in your Kubernetes journey? And Cody will pull that up. Are you just learning about containers and Kubernetes? Are you planning on using it in the next 6 to 12 months? Maybe you're only using it in testing or development. Or are you already using it in production? And we use this same poll kind of in all of our webinars and sort of track people's progress into Kubernetes over time. And so it's a useful detail for us. Click a button. Tell us where you are. Good to have a feeling as we go. Also, there is a place in this tool, Big Marker, that we're using, where you can ask questions. So as we go, feel free to go over to the Q&A tab, type in a question or two, and we will try to address those either as they come up or towards the end we'll have some time for question and answer. We're always happy to answer questions, preferably on topic, but you can be slightly off topic if you need to. And here's the results coming in. So the majority of you still just learning about containers and Kubernetes, and then the other largest bit being using it in production. This tends to be the spread that we've seen, although I'm a little surprised by the number of people just still in the learning about phase. But if you're going to be learning about Kubernetes, learn about the guardrails now. There's a lot of organizations out there who buy our software just so they avoid making all the common mistakes that people do. So we'll give that about 5 more seconds. Oh, nope, never mind. We're all done. We're all done with that poll. We'll move on. It's good. We've got one more poll later on, so we'll keep coming. Thank you for sharing. So real quick, what are guardrails? We have a dictionary definition here. A strong fence at the side of a road or in the middle of an expressway intended to reduce the risk of serious accidents, or a rail that prevents people from falling off or being hit by something. So I think this is obvious to probably at least most native English speakers, whether you're that or not, but that's what a guardrail is, right? There's something going on and you want something, a guardrail in place just to keep you a little safer, keep you from messing up. And here's a real messed up, bent guardrail, but literally this is the job of the guardrail, is to take the brunt of the accident so that you don't go over the side and have serious bodily harm, serious bodily injury, right, Robert? I'm
Exactly.
getting an idea, right?
Yeah. I think the corollary there is that it will also prevent you from going off-roading if you're like, a really adventurous type. Having those guardrails there might be a little frustrating to you if you really want to live life on the edge. But it's really important for the 99.9% of us that would rather just stay on the road and, not.
Yes, very good. So let's start right there. So what are Kubernetes guardrails and why do we care? And to your point, Robert, I think I want to start right there, that there is a class of people out there who they want a Wild West in their Kubernetes environment. They want to be able to do anything. They want to be able to go anywhere. They want to be able to SSH into a specific container and make a change while it's running live in production, even though we would probably encourage you not to do that in most situations, or set crazy network policy, or there's a group of people out there who are building things in Kubernetes. They want to go off-road. They want to go around the guardrails. They want to be able to do anything they can, but that's not the case for the vast majority of people. And talk a little bit about why that is, Robert.
Yeah, so I mean, if you're an engineering team of one, or if you're the only person who interacts with your Kubernetes clusters, and all your development teams are just handing things off to you, you probably don't really need or want guardrails because they're just going to slow you down, and you already know everything there is to know about Kubernetes. You're not going to screw up your own environment. Where guardrails are really handy is when you have many different people who are interacting with the Kubernetes cluster, which is a very typical and recommended setup for an organization, is that you have an ops team that's in charge of the core Kubernetes cluster, and you have a bunch of development teams who are able to deploy to a specific namespace or deploy specific resources to that cluster. So, this is the idea of DevOps, is the development teams get to own their release process. They get to own how their application runs in production. And when you're doing that, when you're giving those teams that responsibility to deploy their own resources to the cluster, you need to make sure that they're set up for success, that they're not able to do things that they shouldn't be able to do, right? And so at a very high level, that could be just like role-based access control that says like, okay, development teams can't like delete anything out of the kube system namespace, which is going to completely blow up the cluster. They can only interact with things inside of their application namespace, that sort of thing. But it also comes into you can get a lot more fine-grained with it, saying, I don't want my application team to deploy things as root. I don't want them to, do any other thing that might, tip over the cluster, tip over their application. We want to make sure that all our development teams are adhering to best practices, adhering to our company's standards, that sort of thing.
And when I'm Joe developer, just your average developer, particularly in an environment where there is service ownership, and it's my job to build my application, ship my application through CI/CD, make sure my application's up and running in a testing environment or in production. I don't want to have to know Kubernetes inside and out. I want to know Node or Go or whatever the language is that I'm responsible for writing in. And when people give me guardrails, it gives me confidence that I can go do things in production. Think about your new developer who shows up, especially in organizations that are like really cloud native, cloud first, constant, constantly delivering. And you show up in the organization, everyone's like, welcome. Day one, you're going to push code through to production. If there's no guardrails, that is terrifying, right? It's giving somebody way too high powered of a car and very tight, windy roads that they've never driven before and saying good luck. So there's you're going to have significant benefit from having really good guardrails. People are going to feel safer in what they're doing by having good guardrails. So it's going to prevent developers from accidentally introducing risk, and a developer does not want to introduce risk. They don't want to mess anything up. They just want to ship their code. And so, it's the same with wasting cloud resources. Okay, sometimes your developer wants to waste cloud resources because they want to over-provision things so they don't have to worry about it. But if you can give them guardrails that says, here's how to provision it the right way, that's going to help give them confidence as well. So all of these things, there's times where guardrails are annoying for a very small percentage of the population. But the rest of the time, when I'm driving around a windy road, and I live near the mountains in Colorado, and I think of one specific road that's here, and if I'm going up that road, my family is pretty freaked out the whole time I'm driving, even if I'm going slow as heck. But when there are guardrails, everybody feels better about it, myself included, because they're kind of hairy roads. Yeah. Anything more to say about that? We've talked about what they are. We've talked about why we care. I think we've also talked about why developers care. Touch for a second, Robert, before we move on why your executives care for you to have implemented guardrails.
Yeah, no, it's a great question. The big things that are going to bubble up to the executive team if they become problems are reliability issues. Things like your application's going down, customers complaining because they can't access your app, or you're losing revenue because your store is not available for purchases. Things like security issues. So if somebody breaks in, steals all your customer data, that can be an issue, and guardrails can help prevent those security issues. And then also cloud cost, right? If your application is misbehaving, using a lot more memory or CPU than it should, or scaling in a way that it shouldn't, that can cost you, potentially tens of thousands of dollars, per month that it's doing this. And sometimes even just a few days of misbehavior can really impact your organization's budget. And so those are things that the executive team is going to hear about if they go wrong. They're the kinds of things that are easily preventable with guardrails.
And guardrails also are a sort of ongoing audit. Rather than waiting for things to be in production and broken, that's like literally waiting for there to be a car accident on the side of the road and going and responding. We're putting things in place to keep that from happening. And your CISO is going to appreciate that. Your CEO is going to appreciate that. Your CTO is going to appreciate that. All the way up the executive chain. They don't want to wait until things are broken to go respond. They want to avoid things being broken. So this is a topic that should be near and dear to your entire organization's heart.
Yeah. My rule of thumb, and I say this as a developer, is that until your development teams are complaining about the guardrails being too strict, they're probably not strict enough. Once you start getting a couple of complaints, like I can't deploy my app because it's saying I need to set XY field, whatever it is, then okay, maybe our guardrails can be loosened a little bit. But until you hit that point, you probably need more structure. Typically, companies err much more on the side of not having enough guardrails.
Yeah, and at Fairwinds, we focus on two major categories of those guardrails. One is cost and reliability, and the other is security. So we're going to talk a little bit about both of those. These are the guardrails that most people really care about. You want your application to be up. You want it to be, it's a shame. And I think it's funny to say that, but it is a shame to run in the cloud and not leverage the benefits of the cloud, which is letting your usage, letting your cost match your actual usage. So getting cost right, getting reliability right in the cloud, these are some of the highest priorities for a Kubernetes environment or for people running applications in Kubernetes. But let's start there. Robert, talk to us about cost and reliability. What are some sample guardrails that matter, and why should they matter?
Yeah, so the first point here talks about health probes. So liveness and readiness probes in Kubernetes are a concept basically that allow you to tell Kubernetes whether your application is healthy, whether it's going to serve traffic, et cetera. If your application starts up, it might need some time to say connect to a database or do some preparation before it's actually ready to serve traffic. You want Kubernetes to start diverting traffic to your application before that starts. And if your application, say, loses connection to its database, whatever else, you want Kubernetes to start diverting traffic away from that particular instance of the application to other instances that are healthier. And so liveness and readiness probes give your application a way to tell Kubernetes, hey, I'm healthy, hey, I'm ready to serve traffic. Those are super important for doing things like zero downtime deployments, for making sure you have a highly available application, things like that.
Yeah, and I mean, it's funny. I'm laughing before I even open my mouth because it seems like an obvious thing to have liveness and readiness probes, but there are an awful lot of places who don't have liveness probes or readiness probes. I'm thinking of one specific example where a good friend of mine, who is the head of engineering for a well-known SaaS application now. At one point, I was talking to another friend about that, and I was like, "Hey, have you heard of this product?" And I went to the website to send it to him, and I noticed their main website was down. And I pinged the head of engineering, and I'm like, "Hey, your website's down." He's like, "Wait, what? It is? How do we not know about this?" And I remember thinking, "Yeah, how do you not know about this? That's a problem." And this is. It seems obvious, but there's an awful lot of places not doing it. Keep going. Talk about the next one.
Yeah. So another big class of issues here are CPU requests and limits and memory requests and limits. So this is the way developers are supposed to tell Kubernetes how much CPU and how much memory their application is expected to use per instance that's running. This is super important because you want to make sure that you've requested a certain amount of CPU and memory to make sure that that is always available for your application to use. Even if, right now it's idle and it's not using any CPU, but when it's got normal usage, it's going to use, say, half of a CPU. You want to make sure that half a CPU is reserved for your application to use. Otherwise, Kubernetes might bin pack a bunch of applications onto this node, and it might look and say, oh, this application's only using one, 0 CPUs right now, or 0.01 CPUs. I can put a bunch of stuff on that node, and that application tries to actually do its thing, and it has no space to move. So you can tell Kubernetes, always reserve half a CPU for this application. Super important for reliability reasons. Similarly, set limits to make sure that it's not going to, if you have a memory leak, say, that Kubernetes catches that and kills that particular instance of the application as the memory starts to leak, so that you don't just start using gigabytes and gigabytes of memory and you use an entire node's worth of memory, potentially hurting other applications.
And I want to say on both of those things, like, part of the beauty of Kubernetes is, before Kubernetes, you had to monitor what your CPU was doing. You had to monitor what your memory was doing and stay on top of it all the time. And you had to go in and roll nodes when they were behaving poorly. Or you had to custom write the automation to monitor those things and roll those nodes. With Kubernetes, all you have to do is set. And it's just like a line in YAML that says this is what they should be. And Kubernetes does the rest for you. And so it will notice, hey, there's a problem, and roll that node. Or roll that container, and there's no reason to not do that. In the same way, there's no reason to drive outside the lines and go down off of a hill, right? Like, you're not doing that on purpose. You're driving down the road thinking you're staying on the road, but and doing everything you can to stay on the road. But sometimes you make a mistake, and all it takes is a guardrail to just stop you and say, hey, you forgot a thing. Hey, maybe don't drive off that cliff. Sorry, keep going, Rob.
One of the themes you'll notice today is that there are a lot of pieces of Kubernetes configuration that are technically optional. Kubernetes wants to make it easy for you to use Kubernetes, so you can define a very minimal deployment YAML and get your application running. But there are a lot of fields that should be set according to best practices if you want, a truly reliable production-ready application. Kubernetes will happily, let you not set those fields, and you really need guardrails in place to make sure that your development teams are setting those fields. So that includes liveness and readiness probes. It includes CPU requests and limits here. But in addition to making sure those fields are set, you also have to make sure they're set to something reasonable, right? So we have another bullet point here for memory and CPU limits and requests being too high or too low. If they're too high, you're probably overspending, right? If you're telling Kubernetes, reserve me 10 gigabytes of memory for every instance of this application, and it only needs 1 gigabyte of memory, you're spending 10x more than you need to, because no other application can use that memory. Similarly, if you're setting it too low, the application doesn't have enough resources to do its job, and could potentially lead to outages or just like slowness in the application. So making sure those are set properly is really important. We have some tools that will actually look at the running application and watch how much CPU and how much memory it's using over time, and then make recommendations based on that in order for you to guide you how to set your memory and CPU.
And that's something I want to touch on. Is some of these are binary; they're either on or they're not.
Yeah.
Did you set memory requests and limits or not? That's a thing you can leave this webinar and go check. Hey, have I set these things? What's harder to know is, what do I set them to? What are the same defaults? And that's really where Fairwinds can help. And we'll get into some of this again later on. We have a whole bunch of open source, and our SaaS software is going to make these things obvious and easy for you. We know that people struggle with setting memory requests and limits to the right thing. It's hard to know. I deployed my app. I think it's probably going to run, but it's real easy to wildly over provision or wildly under provision. And unless you have tooling that shows you what things should be, it's really easy to mess that up. So you can do it. We can help. We're not the Home Depot. That's probably trademarked, and I can't say that. But you get the idea. I have in here a picture of the old style bumpers in bowling. So we've given the imagery of the guardrail on the side of the road that's supposed to keep you from dying. There's also, what I like about this imagery is this makes it easier to have fun when you don't know what you're doing. And when people are new to Kubernetes, it's not fun if every time you're deploying something into any environment, you're just making mistake after mistake after mistake and causing all kinds of problems. Good guardrails are both there to keep you from dying, great, but also there to make it easier, make it more fun until you get the hang of it. You're going to eventually learn the defaults because you're going to have those guardrails in place. You're going to get better at it. You're not going to have to bounce off the inflatable guardrails at the bowling alley over and over again forever. But until you learn how to stay in your lane, it's nice to have these helpful things along the way. I recognize that this is ridiculous imagery, but it makes me happy.
I mentioned earlier that you should be deploying as many guardrails as you can without development teams complaining, which makes it sound like guardrails are just a pain for development teams. But honestly, when guardrails are done right, they make development teams so much happier because they can do their thing, they can do their job without worrying, without getting that knot in their stomach. Like, am I going to take down production when I, click this button or type this command? If they know they're going to be prevented from doing anything terribly stupid, it just makes the whole process feel a lot better.
Yeah. Well, and where this analogy breaks down is part of the fun of bowling for a senior person is not needing the guardrails, because sometimes you mess up and get a gutter ball. But in your production environment, you don't ever want to mess up and get a gutter ball. That's not part of the fun. You're trying to avoid that at all costs, all the time, every time. You don't need to deploy a little log4j with a known vulnerability into your production environment just to keep things interesting. That's not the goal. So good guardrails help make that easier. Okay, let's talk about security. Shift gears. Give us some examples of security problems and guardrails we should have around that.
Yeah, so security is a big one with Kubernetes, where the default configuration for a deployment is not the most secure configuration for a deployment. There are a lot of options available for how to run a Docker container inside of Kubernetes, where Kubernetes is a little overly permissive sometimes, just to make sure that most applications are able to run without too much of a hassle. Because sometimes doing the tightest security means modifying your Docker file, say, in order to make it happy. So some things like our Kubernetes will allow your application to run as root by default. That's a flag you have to set in the security context of your deployment YAML saying, hey, I don't want this application to be allowed to run as root. Super important to set that because, basically if somebody manages to escape the container, if it's running as root, they now have root access on the host node. They can access all the other containers. Like they can do all sorts of crazy stuff.
It's important to say that's not super far-fetched. There are an awful lot of security people who spend their entire career learning how to escape containers and get root access to the node and then start to clunk around the system. And that is exactly how a malicious actor will act.
Yeah, a common theme of Kubernetes security is that you want to make sure that if you have a vulnerable application, somebody ships an app, with source code that's just going to allow command execution or database access or whatever, you want to make sure that blast radius is contained, right? And this is what Kubernetes security settings do really well, is they make sure that if one application gets compromised, it doesn't compromise everything else that's running alongside that application.
Great.
It's similar for things like capabilities that can be added to containerized applications. Some are added by default. Some need to be added specifically. We recommend just dropping all capabilities unless you have special needs there for your particular application. Another class of security vulnerabilities, though, is around vulnerable Docker images. So you are probably building your Docker images, say from Alpine or an Ubuntu image, or maybe like a Node.js image or something like that. And you might be installing applications on top of that. And at any point in the Docker build process, there might be known vulnerabilities that are getting introduced there. So it's possible to scan all those images against the database of known vulnerabilities and make sure that the images that you're deploying into Kubernetes don't have any critical vulnerabilities, or hopefully don't have any vulnerabilities at all. So making sure you're doing some kind of image scanning, maybe blocking in CI/CD saying, hey, we found a vulnerability in this image, you can't continue until it gets fixed.
Great. Yeah, there's, again, back to my comment at the beginning of this around your CISO will appreciate this. One thing that platform teams, engineers do not appreciate is one more security tool that they have to log into and audit their environment. And not everybody appreciates security tools at all, but the way you're going to keep your engineers happy is by integrating security tools into tooling that you already use. And every developer is used to every developer at a fast-moving cloud-native environment with CI/CD integrated is used to CI/CD tools. And integrating into something like CI or CD so that the developer's living in a workflow that they already understand, getting feedback in a place they're used to getting feedback. That's the kind of thing that enables service ownership, doesn't make your developers angry, and keeps your CISO happy because it's tooling that they're going to actually use. So that's significant from the security side. Okay, let's keep going. Well, did you have anything else to say, Robert?
I was just gonna say that the word for that is the idea of shifting left, right? It's a very important thing. That the worst things companies do is developers will ship, then the security team will see on a dashboard like, oh, X happened, and then they'll file a ticket against the development team. The development team has to context switch from whatever they've started doing and go back to the thing they already shipped. It just creates this feedback loop that is super slow and just causes a lot of pain. And so shifting those findings left early in the development process so that they get caught before they get into production, A, means you're more secure, and B, means you're moving faster because your developers aren't constantly context switching. Yeah.
So I only have one more image of guardrails that I'm going to pull through, but I get a big kick out of these. So I'm gonna pull this up. But the background on this image is I'm a developer who's 15 years into my career. I've deployed into all kinds of environments, but never to Kubernetes. I've heard terrifying stories about Kubernetes. I'm supposed to go deploy something that I've never, I haven't had to put it in a container myself. I haven't had to configure that container. I have not had to set, the policies that keep, I have never had to set policy or set the settings on my container to keep it from having insecure capabilities, whatever. All of these things, It can be overwhelming. It's a little like trying to cross a bridge like this for the very first time if there's no railings on it, right? This is a terrifying thing to do, period, even with railings. But at least you've got something to hold on to, and you can go real slow, take your time. It's good guardrails, right? You don't feel like you're going to die. If this bridge existed without those guardrails, it would be certain death. And I think that it's an apt description for a lot of reasons. Yeah, anything I'm missing there before I go on? I love this picture. It makes me happy.
That's a good picture.
54% of organizations are leaving over half their workloads open to privilege escalation. Unless you're chasing Indiana Jones across the bridge, that's true. But I try, as a general rule, in my day job at work using Kubernetes to never chase Indiana Jones, just as a general rule. 54% of companies are leaving over half their workloads open to privilege escalation and thus security holes. This is from a Kubernetes benchmark report that we've put together across lots and lots of organizations. So there's a lot of organizations out there that are not securing their workloads, leaving them open to privilege escalation. The reason that that's easy to do is lack of guardrails.
It's interesting when you look at the benchmark report there, which I think we might link to later for folks who want to download it. But you typically see for a lot of these settings, especially the ones that aren't set by default, a very what do you call it? Binomial distribution. You basically see two big spikes. One where the big enterprises who are good at guardrails are fixing all of these issues, and then you see a spike at the other end with the companies that aren't setting any guardrails at all, or just living fast and loose, and all of their workloads are totally exposed. So you can see some companies care very deeply, and some companies don't know enough to care or put in the guardrails.
Have sane defaults. Get the same defaults from people who can give you sane defaults. Use software to enforce the same defaults so that you don't have to build it all from scratch. We can help. Okay, I'm going to keep going. So where do we implement the guardrails? This is helpful for talking about the different stages that all need guardrails. And Robert, let's talk through this diagram briefly.
Yeah, so we really see three major points where there should be some kind of guardrails or checks in place. The furthest left you can go CI/CD. So you're probably storing your infrastructure as code or your Docker files, etc., inside of a Git repository. Hopefully you are. When those change, when somebody makes a pull request, you should be scanning the changes in that pull request to see if they're going to introduce any new issues. And then you can add feedback to that pull request using those scanning tools. You can say, you can maybe block the pull request and say, these are hard stops, like you can't introduce an image with critical vulnerabilities, or you can't run a container as root, whatever it is. So you can block the pull request there. You can also just surface a warning there and say, hey, you didn't set your CPU limits. We strongly recommend you set your CPU limits, and still allow that pull request to go through. So you can kind of configure how strict you want to be at this earliest stage in the cycle. And so that's the Git repo to the continuous integration process, where you're constantly scanning that infrastructure as code repo, providing feedback to the developers at pull request time and at merge time to say, here are the issues that were introduced here, and blocking things that are big problems. Yeah.
Wait, before you go on, Robert, I do just want to say, hey, I see that there are questions coming in. I do see these questions. We will get to these questions. There's a better place a little bit later on to answer these too. So, but please keep the questions coming. I like it when we get questions in these. So keep going, Robert.
Well, so the next stage in the process is, maybe your infrastructure as code changes, your PR got merged. They're now in the main branch of your repository, and now they're going to get shipped off somewhere through a CD process. There's probably a Docker image that gets shipped to an image repository, and maybe some deployment that goes into a Kubernetes cluster. What you want to have is something sitting at the admission point in this process that's basically sitting typically an admission controller inside of a Kubernetes cluster, watching everything that's coming into that cluster, and it has an opportunity to say, I'm going to reject this and not allow this into the cluster. So this is super important for like your highest priority things that you never want to see shipped into your cluster. say like a container running as root or a privileged container, the admission controller gets a chance to say, I'm not going to allow this in. This is important in case, somebody maybe force merges something into your Git repository to kick off that CD process, or you've got an engineer who's circumvented your infrastructure as code repository and is just like typing things on the command line, maybe an automated process that's like trying to pull in a new deployment. The admission controller I like to think of as like a bouncer for your cluster, or like a customs control for your cluster. They're checking every package that's coming in and making sure there's nothing illegal in here.
Which to me, what I picture is your organization sets in place all of this policy, and in CI/CD catches 95% of anything that would be a problem. But you've got 2 or 3 rogue engineers who really believe they're better than whatever the policy is, and they can just skirt around it. Or, I mean, honestly, the less nefarious example of that is you had a production issue. Somebody is up late at night trying to just push something in real quick to fix it. And they know the way around the CI process, so they're just going to push it in. But it turns out they're deploying something with a known vulnerability. And you also don't want to fix a problem with another big problem. And so, there's a reason to have this extra step. But keep going, Robert.
Yeah, typically we'll see companies have they'll have many more checks at the CI/CD phase and be a little less strict at the admission phase, right? You want to kind of surface those warnings early on in the process, and hope that you catch them all there, and then basically only the things that you definitely never want to see in your cluster sit at the admission phase, because it's a lot easier to deal with problems at the Git phase than when like a cluster is telling you can't deploy and you've got an outage and you're trying to fix things.
Yeah.
So
right. And then runtime.
So the third piece of the puzzle here is to make sure you're continuously scanning the things that are already in your production environment. So say, you have an image that's getting deployed, you've scanned it in CI/CD, there were no vulnerabilities found, you deploy it into production, the production cluster is running it, and then, 2 days later, a new CVE gets announced. It turns out that image really is vulnerable. We just didn't know it at the time. You want to make sure you're continuously scanning everything inside the cluster and surfacing up that newly found vulnerability so that this image that got deployed 2 days ago, now it's vulnerable. We need to go back and fix it and go through this process again. So making sure you constantly have eyes on kind of the true state of things inside the cluster is super important. It may not fit under the guise of guardrails specifically because it's already in production. We can no longer really stop it from being a problem. But you need to know that those problems exist so that you can kind of go back to the beginning of your process and fix them.
Yeah, I mean, I keep using the Log4j example, but there was a day where you could ship Log4j and it would pass CI/CD even if you're scanning for vulnerabilities, and it would pass the admission controller even if you're scanning for that, and it would be running in runtime totally fine. And the next day, it's running with a known issue, and you want runtime to also be aware of that. Right? You can deploy everything just fine, and you can still have problems running in runtime because we notice problems later on, and so you want to make sure you have a way to check for all of those things.
Go ahead. I was going to say another important piece of the runtime part is that if you have a new policy you want to deploy, say you want to make sure all your apps are labeled with a cost center code, you want to get eyes on what apps do I have currently running that don't meet this policy that are suddenly going to get blocked in deployment when I deploy this policy? So you can kind of run that policy against your live infrastructure for a little bit, just to see who's fixed it so far, et cetera, before you start blocking an admission control for any app that doesn't have a cost center code. And it lets you kind of roll things out slowly and have a sense for the impact once you put it in blocking mode.
Yeah, which, to be clear, guardrails in this situation in runtime do not go in and kill everything that's not acting right. It bubbles it up. You don't want to have an automated way to start shutting everything down unless you're really good with the chaos monkeys. Okay, so let's talk about how to implement guardrails. I've hinted at several different things here, and we are going to talk about some of our open source, some ways to write custom policy, and then also our software for handling this at scale in multi-cluster environments. Start with the overview, Robert, and then I'm going to go to one of the questions that we had come in because it's specific to this.
Yeah, so implementing guardrails at each step in this process, in CI/CD and admission control, and inside a live running cluster is not super easy to do, especially if you want to run the same checks in each environment and kind of customize how each check runs, whether it's in block mode or passive mode, that kind of thing. So we highly recommend utilizing some open source or commercial tooling to help you with that process. We provide a handful of open source tools that are free for anybody to use. Polaris is great for checking basic deployment configuration, things like setting those liveness and readiness probes, setting CPU and memory settings, basic security settings like not running as root. Polaris can check all those things, and it can do that again in CI/CD. It can check your infrastructure as code files. In admission control, it can block certain things that don't meet those checks, and it can run against the live cluster to see, okay, what's already in my environment that doesn't meet those things. Goldilocks is a great tool for making sure you have your CPU and memory settings set just right. That's the Goldilocks name, as we get it just right. It looks at the running application, determines how much CPU and memory it's actually using, and then compares that to the memory requests and limits, the CPU requests and limits, and makes suggestions as to what those should be set to.
And one thing I want to add about Goldilocks is, and correct me if I'm wrong about this, Robert, but it leverages data that Kubernetes is already collecting in the vertical pod autoscaler. And so you can install Goldilocks and immediately get suggestions. You don't have to install it and let it run for a week before you get suggestions. You can run Goldilocks and immediately pull out meaningful data that's actually accurate, assuming you've been running Kubernetes for more than 5 minutes.
Yeah. The other two that we offer here are Nova and Pluto, and they check for, Nova checks for outdated and deprecated Helm charts. So if there are updates there that are available, it can kind of force you to update. And Pluto will check for deprecated or removed API versions. Kubernetes, as they release new minor versions, 1.22 is a big one where they removed a bunch of old API versions, and suddenly all your deployments are going to break if they haven't been fixed to use the new API version. So Pluto can check for those things. We also suggest if you have custom policies, so all the ones we've talked about really have like a built-in set of best practices that they check for. If you have custom things, like we talked about, maybe having a custom cost center code on every single deployment. If you have things that are really specific to your organization and aren't things that other organizations are already going to have built, you can use OPA, and actually Polaris now also has support for custom checks. So you can write your own checks to make sure your company name is tagged on every deployment, whatever it is you want to do with your company. You can have that set up.
And I want to add too, you can write custom policy in Polaris as well. Polaris has a way to do that. So OPA has kind of become the standard for custom policy, but Polaris has been around since even before that. And so we've had a way to write custom policy there as well. There's some things about the way that Polaris's custom policy code works that might be easier to approach, but that's a personal opinion. So you can check out both.
The general trade-off there is OPA is much more powerful. It's basically a whole programming language, but Polaris covers 95% of the use cases with a much simpler syntax. Uses JSON schema, which is a standard that's used by Kubernetes to validate things.
Yeah. And then talk about multi-cluster environments with Fairwinds Insights.
Yeah, so each of these solutions on the open source side of things is fairly easy to deploy for a single cluster, for a small use case, for a single development team, that kind of thing, single application. Once you get to bigger environments and you're deploying these policies across many different clusters or enforcing them across many different development teams, things start to get a little bit more hairy. Development team A needs an exception for this particular policy. You want to make sure these policies run in production, but not staging, or run in your EU clusters, but not your North America clusters. Things start to get very complicated in larger environments. And in that case, it can be easier to use a centralized commercial system that can take in all these policies and federate them out to different locations. It can run, the same policies across all your CI/CD environments, all your admission controller environments, all your in-cluster scanning, and they can be configured on a per cluster basis, a per namespace basis, that sort of thing. So we actually built Fairwinds Insights, our commercial product, with this idea in mind. It's basically a platform that any open source tooling can plug into. We have plugins for each of the open source tools listed here. So Polaris, Goldilocks, Pluto, OPA, some other ones like KubeBench and KubeHunter, Trivy, container scanning. Those all plug into Insights, and then Insights can make sure they run consistently across all 3 stages of the development cycle, so CI/CD, admission control, and in-cluster scanning, and across your entire fleet of clusters, your all your repositories, that sort of thing. Make sure you to configure all these different checks for each specific environment.
Yeah, and I'm going to show you that in just a second, so we can hang on. And Robert, you broke up for me there for just a second. Am I clear for you before I go on?
You are clear, yeah.
Okay. So one of the questions that came through, and let's answer this now, and then we'll dive into a demo of Insights and come back to the other questions. But says, we have GitLab as CI/CD platform, SAST scan, DAST, dependency, container scans, etc. are all familiar terms. We are in the early stages of rolling out security for containers. Do you have any specific guidelines on top 5 things? Say, RBAC, secret management for container security. And I don't know if you want to list your top 5 priorities, but maybe where to go, like what, even some of these tooling, like what's the best way to get some of the top 5 priorities in a default way?
Yeah, so I'll try and come up with 5 off the top of my head. I think you hit 2 perfectly there. One being RBAC, I think is one of the first things you want to do. That's less around container security and more around the security of your Kubernetes environment. Making sure different personas within your organization aren't able to do things that they shouldn't need to be able to do. A developer needs to be able to do less than a platform engineer, and you probably want to reserve the most important things, like being able to exec into a pod for like a cluster admin kind of thing, like only the handful of the break glass type people. Secrets management is another big one, just making sure that you're not including secrets inside of like a hard-coded environment variable so that it's just there for anybody to see, that you're using Kubernetes secrets, that you're encrypting them in your infrastructure as code. Super important. Another one I'll say is just container scanning with a tool like Trivy, making sure you're checking for known vulnerabilities inside your container images, super important. Kubernetes configuration security, so making sure you're not running containers as root, making sure you're not allowing privilege escalation, things like that. Those are things that Polaris can help check for. I think that gets me to 4. And then I will say, which is a little bit more advanced. We don't see every company do it, but it's definitely a good idea. If you're security conscious, work policy, making sure, by default, we have another question that touches on this. By default, every other pod. And it's good. It's a good idea to start to tighten that down, because in most cases, application A doesn't need to talk to application B, it doesn't need to connect to application B's database. And so making sure you have probably like a deny by default policy specifically allows, okay, this application can reach these external domains. This application is able to serve traffic to the outside world. This microservice is allowed to talk to this microservice, that sort of thing.
Yeah, great. So also, we have an open source project for managing RBAC called RBAC Manager. We have other open source as well that addresses some of these things, but go check out our GitHub and you can see a bunch of those married together. But let's dive into a quick demo. I'm going to give, this is, the software I'm about to show you, Fairwinds Insights, is a very comprehensive piece of software already in a lot of ways. There is a lot that you can do with it, and I can't show you everything in the brief period that we have. My hope is to whet your appetite. If you're interested in seeing more, reach out and we can show you more in depth. But let's dive in and let me give you an overview. So when you log into Fairwinds Insights, this is what you're going to see. Well, I've actually already clicked on clusters instead of home, but I've got an overview of all of my clusters, an overall health score for each cluster, as well as the number of action items that are need to be addressed in each cluster, and then I have an overall health score for my entire organization. So if I click into one of these, and I've actually got this pulled up, Proxima Prod, so here's one of the clusters that I could dig into, and I get an overview of this particular cluster. So everything above the line is when action items are introduced to the cluster, and everything below the line is when we have knocked out some of those action items. So you can see, that in theory, we're improving this cluster over time. And, you can see the health score used to be 89. Today it's 91. That's why we have an A- on this. We're checking for a whole bunch of different things. Only 26 issues are critical. Most, the vast majority of things that we're checking for are actually passing. We do have some cost analysis on here as well, which I'll get into in a second. So where is this all coming from? we're pulling reports from a whole bunch of different places, and Robert touched on this. Polaris is our software, Nova, Pluto here to give you a high-level overview for. But we do include Trivy for container vulnerabilities, Kubebench, KubeHunter, and we also support Open Policy Agent in Fairwinds Insights. So that will roll all up into a big, long list of action items. And right now I'm looking across the entire organization, but you can filter by category or by severity or all of the above. You can look at specific clusters. And if you click into any issue, it's going to tell you both what the issue is, a description of it, as well as how to go about fixing it. So you don't have to be a super senior engineer in order to be able to dig through this and knock issues off. Now, if you're like me and you work, I'm not on the platform team, but if I was on a platform team, I would not want to have a gigantic list of all the things my organization did wrong with no way of improving it other than just waiting for Kendall to go knock through this list. And so this is why we've spent so much time talking about guardrails. When you shift this left into the CI/CD pipeline or into the admission controller level, now you've put guardrails around instead of waiting for things to be broken in production and respond. So rather than being help desk that people call because, hey, 911, I drove off the side of the road, or whatever, which a lot of SREs hate being help desk because people just call and say, things broke, what broke, right? Instead, you put same policy in place, and it's going to live in a place that developers are familiar with. So here you can see, a workflow that an engineer is going to be very familiar with. They're pushing code into GitHub. There's a pull request here, and you can see Circle CI has passed the tests, and Fairwinds Insights has failed. So an average engineer can just live in here, click details. It's going to load them into the UI and show them what they need to fix so that this deployment will go through. You can also get there from within the GUI. You can go in, click on a repository. Here I have a repository with 3 critical action items, and I can click into this, find what those critical action items are. Oh, Trivy's telling me that I'm running something with a known CVE, and it's going to tell me how to go about fixing it. So there's this is all of that policy shifted left, and you can set defaults. I want to block any push, any pull request that has critical vulnerabilities or high or above vulnerabilities. You can set these different thresholds and keep your people from doing things you don't want them to do. We also do have some efficiency dashboards where we track cost over time. You can click into specific workloads. Once I select a cluster, and I got to go quicker because we got to wrap up a few things here and answer questions. But we break down specific workloads and offer actual recommendations so that you can see, hey, if I did X, Y, or Z, I would save, here's a cron job running that's costing me $19 a month. And if I took the recommendations, it would only cost me $8.95. I'd click in here and it's going to tell me what I'm actually using versus what I'm requesting. And it's going to tell me the difference and what to go set it to. So this is one of those tools that we mentioned. Everybody has a hard time getting this right. We make it easy. Policy, here's the dashboard to write custom policy. You can click create a custom policy right within here. We have a policy wizard. We have templates. There's a whole bunch in this software that I can't go into everything. Compliance, automation. You can kick everything out to Jira so that you're automatically creating tickets or doing, using a workflow that makes sense to your team, be that Slack or Jira or whatever it is that you're using. There's a lot here. Fairwinds Insights makes it very easy to write custom policy, set defaults that are sane across your organization, and enforce it across everywhere, no matter how many clusters you have. You can use open source and do that on one cluster with relative ease. Use some of our open source. Check out Polaris as a starting point. But if you're running in a large environment, Fairwinds Insights makes this very easy. Okay, let's go back and let's address a few questions here. I just gave the demo. Nope, I don't want to do a poll yet. I want to answer questions first. And the other question that I have here is, by default, Kubernetes provides a flat, unsegregated network where all applications in the cluster can talk to one another. Any guidelines on how to lock it down or harden the container network? And you touched on this briefly, Robert, but give somebody a place to go get started.
Yeah, so totally right. By default, Kubernetes is going to let everybody talk to everybody within the cluster. Again, this falls in the theme of Kubernetes wants to make your life easy, wants to make Kubernetes easy to adopt, which often means not shipping with the tightest security controls possible. So we recommend putting in some kind of network policy in place. By default, the Kubernetes network policy is pretty low level. I think you need to specify like IP addresses, things like that. You don't really get those like higher layer semantics, like being able to specify specific domains, specific paths, things like that. So we also recommend using a project like Linkerd as your network policy provider. That can really help you define sensible network policies that are a little easier to reason about, a little easier to design. I think that really helps. We also suggest starting with a default deny policy, meaning nobody can talk to anybody. And then you slowly layer on, okay, well, this one needs to talk to the Kubernetes API. This one needs to talk to this one. This one needs egress to, the Slack API, something like that. So you start to layer on, the actual things your applications need. That way, you're basically down to the kind of the principle of least privilege, right? Nobody can talk to anybody unless they absolutely need that permission.
Right. Okay, let's do this last poll. I'm going to send you one place to go check out some resources, and then we'll turn it back over to Cody to wrap things up. So tell us what the greatest opportunity is to improve your Kubernetes environment. These questions may seem leading, but these are all things that Fairwinds can help you with. So it's helpful for us to know if we were to reach out, what would be most useful for you. I want to reiterate just a couple of things. Guardrails are essential. They're helpful. They give people confidence, a feeling of safety. It's worth implementing them across your organization. Fairwinds can help. If at all what we talked about today was useful to you on the open source side or the software side, we'd love to talk with you. Please reach out and we can show you more in depth, talk with you specifically about your use case and see how our software can help. So would love to have that conversation if you're interested in that. Here's the results of the poll. Looks like the vast majority of you are looking at improving the security posture of your clusters, which makes sense given the topic of what we're talking about today. Saving money is also up there, and general best practices. So we do have a general best practice assessment here. You can go check out, here I'm showing our benchmark report. So we have a benchmark report. We have a general best practices white paper. We've got a bunch of different things that you can come find from Fairwinds. Also check out our GitHub for open source. Feel free to go to this bit.ly /Fairwinds trial and you can have a conversation with us. We will reach out and follow up. There will be a recording of this, and I'm going to wrap up. So Cody, you've got 3 minutes to handle a drawing. Thank you everyone for coming. This has been Guardrails and Kubernetes. Glad we could be here tonight. All yours.
Thank you, Kendall, and thank you, Robert. Really appreciate both of you hopping on today and sharing your expertise with us. So I would like to remind our audience, make sure I'm unmuted. I would like to remind today's audience that this session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the Container Journal website. Just visit containerjournal.com/webinars and be sure to look in the on-demand section. So onto those 4 gift cards. This is for 4 $25 Amazon gift cards. Our first winner is Kelly W. Our second winner is Jonathan K. Our third winner is Christoph K. And our fourth and final winner is Mbalu K. 3 last names with K. So congratulations to the 4 of you. Please keep an eye on your inbox to claim that gift card. But if you don't happen to see that email, keep an eye on your spam folder. I would like to thank Fairwinds for sponsoring today's webinar. We couldn't have done this without Fairwinds. And to our audience, we really appreciate you spending time with us today. We ask for 1 extra moment of your time to fill out a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Tech-Strong Learning program. Everyone, have a great rest of your day. And Robert, Kendall, thank you once more.